In this video, our goal is to explore the measures of center of a numerical variable. In other words, if you condense data on a numerical variable into a single value, what value should that be? Should it be the mean? Should it be the median? What do we mean by the mean? What do we mean by the median? You see, in the beginning, in Module 1 or Unit 1, we talked about the fact that if we have a population of interest and we are unable to collect data from every unit member of the population, we usually settle for a sample, which is a fractional subset of that population and hopefully represents the population characteristics. If you collected data from the sample and it's all numerical variable, then you can compute what is called the sample mean, represented by x bar. This is the number that we obtain by summing all the numbers collected from sample units and then dividing by how many units are in the sample. Otherwise, if you have the resources to be able to access everyone in the entire population, then you have the population mean to compute based on all values in the entire population. So we're going to write that as mu. So to write mu, which is a Greek letter, write the letter U and then have a slant line to the left. And you have, this is pronounced mu. All right. Then next you have what? Median. The median is another measure of center of a numerical variable. It is the middle value, but it does not necessarily have to be one of the actual values that you collected. In order to find the median, the first step is to order the data values from the smallest value to the largest value. Sometimes to find the median in large data sets can be proved to be very tedious. And so sometimes we can use the location, an index that helps us to figure out the location in order to locate the actual value of the median. And that is given by this formula, which we might not really use, but we'll be using StatCrunch to help us implement technological ways of computing this. So 1, the mean, 2, the median, and then 3, the mode. This is another measure of center for numerical variables, and it is the value in the data set that occurs most frequently. So there are a number of possibilities. If I have numbers like 1, 1, 2, 2, 3, 3, no number occurs more often than the other. In fact, they all occur with uniform frequencies. So this data, in fancy language, will be said to have a uniform distribution. Otherwise, if I have a data set like 1, 3, 2, 1, 2, 1, well, there is only one particular value that occurs very often. This is said to have a unimodal distribution, where the mode is equal to 1. And for a bimodal distribution, then we have a case where two values occur with more frequencies than all other values. In this case, that will be 1 and 2. So for this bimodal distribution, we have modes 1 and 2. And as you might imagine, for a multimodal distribution, if I have 1, 3, 2, 4, 1, and I have 2, 3, and I have 1 again, well, 1, 2, let's include another 2 here, and then what? And 3, let's include another 3. These are all modes in this case. So that's 1, 2, and 3. This constitutes a multimodal distribution. So if we wanted to compute the mean, the mode, the median in StatCrunch, how would we do that? Let's go back here. I'm going to close out of this. And let's say I have data on this numerical variable, and I'd like to compute the mean, the mode, and the median. I'll go to Statistics, and I would need to go to summary statistics for data values in a column. So select columns, and in particular, we want the column weights or create weights. So I'm going to click on create weights, and I'm going to indicate that I want just the mean, and I'm going to scroll down to choose the median. To also select the median, to do multi-selection, remember to hold down the control key and click on median. Holding down the control key, I'll go all the way to mode, and I'd like to compute that. And so I have these values, in which case I have what? The mean, the median, and this says this is multiple modes, so I know that this is not a unimodal distribution. All right, with that said, let us now see how we put these measures to use. In this example, suppose that in a small town of 50 people, one person earns $5 million a year, and each of the other 49 persons, each of them earns $30,000 per year. Intuitively, what would you say is the typical earning of a town resident? Without any calculations, what do you think? I would say that on average, a typical person here tends to make $30,000 per year. So that would be my answer for the typical earning of a town resident. But let's do some computations and let's see if computation agrees with our intuition. For the mean, I would need to add how many 30,000s? Did you say 49? Yes, that's correct. So that would be 30,000 49 times added together with the one person who makes $5 million divided by how many people in total? 50. So that will give us $129,400. That is for the mean. Then for the median, remember we said that should be computed in the following way. First, we'll order all the data values from the smallest to the largest. And after doing that, we'll pick what? The middle value. So if I have 49 30,000s, well, that means if I order the data values, I'll have 30K 49 times, and then the biggest value, which is what? 5 million. No doubt, the middle value here, which is the median, will be $30,000. What do you notice? Now back to original question. Our original question was, based on intuition, what is the typical earning of a person in this town? We said 30,000. Does that align with the mean? Can you imagine telling someone who makes 30,000 a year that you did some statistical analysis and that you know that on average that the mean amount that that person is making is about $129,400? There's no doubt that that would not make that person happy. Not at all. But the median here of 30,000 seems to what? Align with our intuition, which means that the mean is not the only average or typical value that can be computed for numerical variables. Rather, you can have what? The median. And the median in this case more accurately represents the typical value. So, which, the mean or the median, is the best measure? In this case, it is the median. The median is the better measure of center, or typical value of what? Of yearly earnings. And why do we so answer? Because it aligns with our intuition. And you will notice that we might want to ask, why is the mean unusually bigger than what? Than the median? That is because we had an extreme value here, which is 5 million. So you would note that the mean is a sensitive statistic. Is a sensitive statistic that responds to an outlier in a way that makes it unusually inflated. whereas the median is a robust statistic that retains its 30,000 value, which is closer to what intuitively represents reality. And so we know that it's able to do that because the median is a robust statistic that is not unduly affected by the presence of outliers. Now, having talked about the measures of center for a numerical variable, we now want to talk about measures of location of data, and that is namely the percentiles and quartiles. You see, the most common measures of location are percentiles and quartiles. Percentiles is a measure used in statistics to indicate the value below which a given group or set of observations or percentage of all observations or values of all observations in a group or data set falls. Percentiles tend to divide the data into approximately 100 parts. Okay, all right. So, as far as interpreting percentiles is concerned, let us use an example to interpret a percentile correctly. On a timed math test, the first quartile for time it took to finish the exam was 35 minutes. Interpret the first quartile in the context of this situation. All right. For the first quartile, one very important step in interpreting this is to ask, what is the variable of concern? It is the time taken to finish an exam. So, for all students, data was collected on time taken to finish the exam from the smallest, the minimum time, to the maximum time. Well, if we are to divide that into quartiles, that means there is the middle, which will be the median. Then halfway between the median, minimum, and the median is something called the first quartile, represented as Q subscript 1. And between the median and the max is somewhere called the third quartile, represented as Q3. Now you might notice that we have jumped from the first to the third. Where's the second quartile? That is the same as the median. So if we're saying that, back to the context of this question, that the first quartile is 35 minutes, it means this value, the first quartile, is equal to 35, which means that 25% of students completed the exam in 35 minutes or less. That is the implication of that. Again, that means that's 25% of all students, the quarter, finished the exam in 35 minutes or lesser. And that means that the remaining 75% completed the exam in 35 minutes or more. All right, so we should note that quartiles are, as we can see from this picture, a special kind of percentiles, because the first quartile here coincides with the 25th percentile, no doubt about it. And what do you think? The median, the second quartile, that will coincide with what? It will cut off the bottom 50%. And so this is the 50th percentile, whereas the third quartile will be the 75th percentile. So the first quartile is the same as the 25th percentile, written as P subscript 25. The median, M, is also called the 50th percentile, and it's also called the second quartile. Q2, and excuse me, and we have what? P50 here. And then the third quartile, Q3, is the same as the 75th percentile, or P subscript 75. So you see, based on this measures, we define a new measure called the interquartile range. So if we have the stretch of the data values, minimum to the maximum, and you have the median in between, also your 50th percentile, and this is your 25th percentile, and this is your 75th percentile. The gap between the 75th and the 25th percentile, or the gap between your Q1 and Q3, that distance is called your interquartile range. So interquartile range, short for, which is written in short as IQR, is Q3 minus Q1, or 75th percentile minus the 25th percentile. So to calculate quartiles and percentiles, just like the median, data must be ordered in some order of magnitude, from the smallest preferably to the largest. Let us take an example where we consider the following data, raw data, and we have to determine the median, the first quartile, the third quartile, the interquartile range. So let's see. Let's go to StatCrunch. I have that data set here, already provided here. I like to find um, each of these quartiles. So I'm going to go ahead and go to Stats, and I want to find some summary numbers or summary statistics for data in a column. So I'm going to click on columns. And what is the name of that data? I've called it outlier data. Sure. So I'm going to click on outlier data, and let us see what we want to compute. We want the median, the first quartile, and the third quartile. So we can do that here. And so we are going to say we want the median. I'm going to scroll down. Okay, I do not want the max. Let me scroll to median, and you have median here. And then for the percentiles, I want where to enter 30 for 30th. I want 25, and I want 75, which will give me the first quartile and the third quartile. So I would compute this. So I have this data values. So in this case, I can see that my median is 7, my first quartile is 2, and my third quartile is 9. So taking that back, median is equal to 7, the first quartile is 2, and the third quartile is 9. So my interquartile range is Q3 minus Q1, or 9 minus 2, which is equal to 7. Take note that the interquartile range, like the median, is also another example of a robust statistic that is not affected unduly by the presence of outliers.